Hello, algebra students. We are in chapter 7 and we are working on section 7.2, substitution. So this whole chapter has a theme of dealing with these systems of linear equations. And as I mentioned in the last video, there's some algebraic maneuvering that's much more, let's say, streamlined than the graphing method. So we're going to start with the first of those, which is substitution. So what is substitution? Substitution is when you know something about a variable and you substitute that value in for the variable. So let's say that I knew for a fact that 2x plus 3y was equal to 7. And then somebody came along and said, hey, lady, by the way, y is equal to 1. I can substitute 1 into this equation to figure out what x is. So what would that look like? I would take this equation, put 1 in here, and do what I do best, which is to solve an equation with one variable. I'm good at that, right? We are. We've been doing this for several months now. And so now that we can do this pretty easily, we just 7 plus a negative 3 is 4. And then we can solve that that's not the pretty thing I want. We can divide both sides by 2 and get that x is equal to 2. So the line, or the point where these two lines would intersect would be at 2, 1, when x is equal to 2 and y is equal to 1. You might be looking at this and saying, yeah, that's kind of cheap because I kind of gave you one of the answers already, right? And that would be true. So what if I told you that instead of y is equal to 1, another form of substitution you'll see is that you might have a whole other equation that involves both variables. Let's say you had something like this. So now it's a little bit difficult, but it's the same concept. What I do here is take this one of these variables. The x looks really promising because it doesn't have a coefficient other than 1, right? Coefficient, we remember, is the number that we multiply next to a variable, right? So it doesn't have a coefficient greater than 1, so I can easily maneuver this equation so x is by itself. So watch this. X is equal to, add 4y to both sides, 4y minus 2. Pause me if this doesn't make sense. You know how to do this, though. So now that I have a value for x, I can substitute this into the other equation. 2 times, watch this, 4y minus 2. Where am I getting that from? X is 4y minus 2. So I'm plugging it into another equation. That's super important. 3y equals 7. Notice I have one equation with one unknown, which I am a professional at solving. So I'm going to rock a little bit of distributive property. I get 8y minus 4 plus 3y equals 7. I'm going to join like terms together like I've been taught to do. 11y minus 4 equals 7. Move this 4 over to the other side by adding 4 to both sides. I end up with 11y is equal to, add 4 here and here, that cancels out, I get 11. So y is equal to, divide both sides by 11, is equal to 1. We already knew this, right? Because we're using the same x and y values from before. We had y was equal to 1. Now, I'm going to plug that 1 into any equation I like, this one, or even this one, and I get that x is equal to 4 times 1 minus 2, right? Because I'm plugging a 1 in there. I chose this equation because x was already solved for. So that's pretty nice and smart of me. X is equal to 4 minus 2. X is equal to 2. I just did pretty much the entire lesson with talking about that one vocabulary word. So the answer is still 2, 1. So substitution is the process of replacing a variable with other information you have about that variable. And generally what we are going to do when we do substitution is make our lives easier. Even though that was just an example, let's do a couple more. So here we are at example 1. We're going to solve using substitution. So using substitution, what we do is we look around at our equations. We want to see if we could tuck one equation into another. And I think I have two pretty good candidates, right? Y is alone. meaning it has a coefficient of 1, which is easy to solve for. In fact, y is already solved for. And x has a coefficient of 1, which means all I'd have to do is throw the 2y over to the other side. So I can kind of choose any one that I want. I'm going to be lazy since y is already solved for. I'm going to use y. The trick is, by the way, you always have to solve in one equation and substitute into the next equation. Otherwise, you're just going to come up with an identity, which is not helpful. So once you solve for, or if you have one variable solved for in another equation, you've got to substitute it into the next one. So I'm going to do just that. X plus 2 times y. What is y? 3x is equal to negative 21. How do I handle this? Very simply, it is easy. I know how to do this because I've been doing it for a long time. I have been solving equations with one variable almost all of my algebraic life. Okay, let me stop being silly. So I get 7x is equal to negative 21. Divide both sides by 7. And x is equal to negative 3. So I'm done, right? Wrong. Anytime you solve these guys, you're generally looking for two answers, x and y. So let's go back and find y. But pretty easy because here we have this beautiful equation that's already solved for y. We're just going to plug our value for x in there, and we're going to get negative 9, and then we get negative 9, and we've solved our system. Pretty cool, huh? Much better than graphing. So here we have to do a little bit of work. We could substitute, we could literally solve for any variable and just go and substitute whatever we get into the opposite equation. But I'm telling you, I'm always looking for the easy one. And this x is like, solve for me, solve for me. My coefficient's 1. And I'm like, sure thing. So I'm going to do that. I'm going to get x by itself. So I start off with x plus 5y is equal to negative 3. And I'm going to tell 5y to move. Get over there. I don't need you over here. I want x to be alone. So I end up with x is equal to negative 5y minus 3. Make sure that makes sense to you, all right? Now I'm going to take this bit of information and I'm going to plug it into the other equation. Very important. Do not plug it back into the same equation. You will get an identity, which just means like you'll get x equals x if you did all the work, and it's boring. And it doesn't get us anywhere. So let's plug it in here. So I have 3 times a whole lot of stuff. What is x? X is this. Negative 5y minus 3 minus 2y. Notice I'm just picking back up with the equation, what's there. And I'm so happy I've got an equation with one variable, which is awesome. So I'm going to distribute this 3 through. Negative 15y minus 9 minus 2y equals 8. You guys know how this story goes. You've been doing this for a long time, since you were knee-high to a grasshopper. So minus 9 is equal to 8. Add 9 to both sides. We get negative 17y is equal to 17. Woohoo! So negative 17 equals 17y. Just picking back up over here. I'm going to divide both sides by negative 17. I know I sound like I'm mumbling. My bad. I'm going to divide both sides by negative 17. And I get that. No, I'm not. I'm dividing both sides by positive 17 because that's the coefficient that I need to get rid of. My bad, Chablitos. No, I'm dividing by negative 17. I just rewrote the problem wrong. Let me fix it. Okay, so I'm going to divide both sides by negative 17. Negative 17. And swoop delicious, y is equal to negative 1. And I'm done, right? Am I? No, never done. Always have to find two values. So I've got a negative 1 here for my y, and my x value, fortunately for me, I already solved for x. I'm going to pull that original equation out. X is equal to negative 5 times negative 1 minus 3, which is 5 minus 3, which is 2. And so I get 2. You guys are loving this, aren't you? I know you are. Right now you are wondering why we can't do more problems. I understand. I don't know why, but my video's going to try to keep it short, so I won't do too many problems, but let's see what's going on. They told me we were going to get a dependent system here. If you remember, dependent system was a system where the two lines were the same line, so you got infinitely many solutions and it was dependent. Remember Remember? So let's see what happens, because now we're not graphing it to see this visually. Let's see what happens when we plug one equation in for another. So we're doing the substitution method. Y, thankfully, is solved for. So I'm going to take that value and I'm going to tuck it into this other equation. So I get 6x minus 2 times, what's y again? Y is equal to 3x plus 2, which is equal to negative 4. And now I'm going to distribute through 6x minus 6x plus 4, right? Negative 2 times that is negative 6. This times that is equal to negative 4. And now I'm going to join some like terms together. So these guys come together and they cancel each other out. Then I get 4 is equal to 4. Oh. When I have an identity, meaning I'm looking at the same thing, I know that there are, we've talked about this, infinitely many solutions. There's infinitely many solutions, or any number would work, all reals. So any number, well, I don't like that, because I can't just put in any numbers for x and y, but whatever works for x and y in one equation will work for the other, because ultimately these two equations are identical. So you know you have a dependent system, two lines that are exactly the same, because if you work it out when you tuck one equation into the other and you try to solve, you're going to get an identity. No information, a true statement, but nothing that's going to move you forward. Yes, 4 is equal to 4, but there's not much that I can do with that. This problem might look familiar to you because we did this in an earlier chapter where we made elaborate charts and we talked about how to do these problems. And then when it came time for test time, I was like, okay, I'm taking them off the test, because I knew we would come back and talk about them again in a way that might be more palatable. So let's take a look at these types of word problems. Metal alloys. A metal alloy is 25% copper and another metal alloy is 50% copper. How much of each alloy should be used to make 1,000 grams of metal alloy that has a 45% copper percentage, right? So what I have to do is, first, with anything, I have to create my variables and know what the quantities are about. Since they're asking us about the number of grams, I'm going to let x refer to the number of grams of the 25% alloy, and then y, I'm going to let that be the number of grams of the 50% alloy. So this gives me one, I don't know why I put allow, this gives me one equation really quickly. The sum of these two has to equal 1,000. So I've got one equation, x plus y equals 1,000. And then the next thing I need to do is come up with my equation that now gives me information about the percentages. So what this tells me is that if I were to take the 25%, look how I'm doing this, of what's in X, which is the copper alloy, plus which is the copper, right, 25% copper, and this one has 50% copper. If I were to get the right numbers, I should create a situation where the sum of the grams should be 45% copper. Like it should all equal, like the amount of copper here plus the amount of copper here should equal the amount of copper in the sum of these guys together. Does that make sense? I know it looks crazy, but this is what we're going to do. So I take this first equation and I solve for x, and I get that x is equal to 1,000 minus y. And now I'm going to take this equation and everything highlighted, I'm going to replace with this newfound understanding of what x is. I get this new equation with one variable. Now I've got to write some distributive property, which isn't too hard. So I get this lovely equation, right? And then I'm going to join some like terms together. So my 250 hands out here. This is like 0.25 and this is like 0.50. Negative and a positive subtract. Take the sign of the higher number, so it's going to be positive 0.25. Hopefully that makes sense to you. And now I'm going to subtract 250 from both sides. When I do that, I end up with 200. And so I get 0.25y is equal to 200. Divide both sides by 0.25. Don't take out your calculator. We can do it in our heads. 200 divided by 0.25 is 200 divided by 1/4, which is 800. All right, maybe you want to take out your calculator. Don't though. And now we're almost done. If I know that y is 800, then x has to make up the difference, has to be 200. So that's my answer.